Hello, good day for everyone. Uh, Welcome to this video, and my name is Budicahya Bagaskara. In this video, I want to tell you about my graph analysis, time and frequency domain of signal, and transition frequency that you can find in filter. All right. Okay. First of all, we have a case problem. Okay. We will create signal and filter signal with this source signal. Sampling frequency 10,000 Hz, cutoff frequency 3,000 Hz, transition frequency 500 Hz, and passband ripple 0.03 decibels. Okay, we can use it to find specified order, and with the help of the table, we use the beta and each transition it's with 2.9, and you can get 558. Okay. Configure it to low pass because we will use low pass to do this. Window, caser, and 10,000 Hertz and 3,000. And we can view it also. And once we configure it and design it further, you need to export it and use the numerator based on your code. And once we have exported, in my case, it's A, and insert it to a workspace automatically and run the code, we will obtain this result, the signal of time domain and frequency domain and the filtered version of them. Okay, as you can see, since we use a low pass filter, you can see from the frequency domain, the signal frequency above 3000 is filtered out. It's due we set the cutoff frequency in 3000 hertz, and in above 3000 hertz, the filter will cancel any frequency above it and leave it out. Okay. And the below cutoff frequency will let it pass, just like these three frequencies, which is 100, 1100, and 300. Okay, and you can see, as we can see also, the signal is also become a smoother and become less in term of size. We can view it from here. And the top frequency, highest frequency in filter is 2.37. Meanwhile, the unfiltered version is 3.15. We can rule out this is become smaller and smoother. And since this has become symmetrical, we can rule out it has a linear phase signal, which is one of the main characteristic of FER's characteristic filter, yeah. Okay, and for the main difference between the time domain and the frequency domain is the time domain is a signal that we sample it in a respect of time with a scheduled time gap. So in a gap between, for example, 0 until 10 seconds, we sample the signal and we just use it as our next observation, which is a frequency domain signal. Frequency domain signal is a signal that we can receive or obtain from the calculation of Fourier transformation, which we apply that transformation into the time domain, with resulting this frequency domain signal with the respect of the search and search frequency components like the amplitude or the one we need to find out. Okay, and For the transition frequency, we can use the picture below as our main guide or reference to this transition frequency. So, long story short, transition frequency is a frequency that inside the process of ongoing change of band into stop band and vice versa. And vice versa, it means like the reverse of it version. Band to stop band becomes stop band into band. Okay, and in the real life case, or usually, it will shape as a ripple before doing transition, and after transition, it will also be ripple before going into uh infinitely become zero or become stable, yeah, or be or have arrived or into the you know the stable, no, not stable, I mean desired value of its stop band value. Okay, and if we talk about the ideal one, it will have the shape of similar to a digital signal where it contain one and zero. One is high, zero is low. That and the the transition between digital signal is perfectly vertical, just like in this picture. This is the ideal case of filter too. So we want the transition between passband to stopband and vice versa is as instant as possible. But and to achieve this, we can just add more sinusoidal signal to become as closely as accurate, yeah, to cram it the passband and stopband. So the transition signal, the angle, yeah, the angle of transition become more vertical, and can be straight, yeah, straight vertical 90 degrees. It is possible into if we can infinitely add some of sinusoidal signal. And I think that is all from my explanation. Pardon for my explanation if there's very much kekurangan, lack of understanding or knowledge that I deliver to this video, and I hope you can understand me. And if there's any question from this video or from my explanation, don't be shy and just ask me straight away. Okay, and that is all from me. Thank you for attention and time. See you in the next time. Thank you. Assalamualaikum.